Okay, so this is section 11.1. Today we are looking, the objective is to find out the square root of a given number. We have some new vocabulary: principal square root, negative square root, radical, and irrational numbers. The homework for tonight will be section 11.1, page 485, number 1 through 43 all, and it's due by Tuesday at midnight. All right. So when we're talking about square roots, the square root is any number that basically, when you have a number, two numbers that multiply by itself that equal that number underneath the square root. Meaning, let me give you an example. So an operation that yields a number which, when multiplied by itself, produces that given number. Okay, so for instance, when we have the square root of 16, what times itself equals 16? 4 is the square root of 16, because 4 times 4 equals 16. Okay? If a is greater than or equal to 0, and a squared equals b, then a is the square root of b. Okay? So basically, let's just kind of, if we square a number, we know that like when we square 0, we end up with 0. But if I take the root of 0, I also get 0. Okay? If I square 1, 1 squared is 1, and when we take the square root of 1, it still equals 1, because 1 times 1 is. When I square 2, I get 4. When I take the square root of 4, the root is 2, because 2 times 2 equals 4. If I square 3, I get 9, and if I take the square root of 9, we get 3. If I square 4, and I take the square root of 16, I get 4. So, are these inverses? Can we always do this? You'd think so, but not necessarily. Because if I start with a positive number, it works. Okay? But what happens if we start with a negative number? So, if I square it, I get 9. And if I take the root of 9, we get negative 3. So there's no two numbers that will end up with a negative. So it doesn't really work for negatives. So we deal with negatives in a different way. Every positive number has two roots. It has a positive square root or a principal square root and its negative square root. So for instance, call this a principal square root. The square root of 16, generally when you see a square root sign, we're talking about the principal square root, right? That's what we call the principal square root, okay? The way we show a negative root, it's like we put it on the outside, and so it would be something like kind of negative 1 times the quantity of 16 would be negative 1. Oh my God, times 4. Sorry, it's dinner time. The square root of 16 is 4, and so that would be negative 4. The negative root of 16 is negative 4. It's basically like having a negative 1 right there in front of it, and next to means multiply. Okay? So we show our negative roots basically with the negative in front of the square root sign. So when we look for the square root, we're really just talking about the principal root. So if I were trying to figure out what x is equal to, we know on the left we have two possible scenarios. If negative 10 squared equals 100, and also 10 squared. So there's two solutions. But when I'm looking at the principal root, what is x allowed to be? It can only be a positive 10, because there's no two negatives that will multiply by each other that will give you a negative. Okay? So this has two solutions, but when you're rooting it, it has one. So we have to think about that negative root. Simplify each root below and identify as a positive root or a negative root. So I'm going to start with number 1. So the square root of 49 is really equal to 7. Number 2, it's like saying negative 1 times the square root of 25, so that's like negative 1 times 5, so that's negative 5. It's a negative root of 5. Pause the recording and I want you to do 3 through 8. Okay, now let's check our work. So, we've got 7, which is a positive root. We've got negative 5. It's a negative root. Number 3, 144. It's a positive root, and it is 12. Number 4, it's a positive root, and the square root is 4. Okay. Number 5 is a negative root, and the root is 6. Negative 6, sorry. Number 6, it's a positive root, and the root is positive 6. Number 7 is a negative root, and it's a negative root of negative 8. And then number 8 is what we call, it's neither a positive or negative. It's not a real root, because we can't take the square root of a negative. And I've been talking to you guys for a while now about our real numbers, which are made up of the rational and irrational. Okay? Well, this is outside here. This is what we call imaginary. It's the square root of a negative. Okay? Imaginary. Wow, we got a lot going on here that you don't usually get in the classroom. Okay, now that I got off the phone with my mom, let's move on. So negative numbers do not have real roots, okay? As in real number system. That's what we mean by that. Okay, some square roots need to be estimated using a calculator. Okay, there's a couple different ways that I kind of teach this. Forget about the calculator. You have to learn how to estimate. Just stop. Just stop. You have to learn to estimate this without a calculator, because you're not going to have a calculator on a test. So there's a couple different ways we could ask you to find the square root. We could ask you to estimate it between what perfect squares, or we can actually estimate this. I have 3 different ways that we can do this. So the first way is, I like to find the perfect squares this falls between. And I can usually guess the estimated to the 10th, usually be within 1/10 or 2/10 of the actual square root of 21. So we know that the square root of 21 falls in between what perfect squares? The perfect square that comes before that would be 16, and the perfect square that comes after that would be 25. So if I have the square root of 16, which is 4, and then I were to take all these others, you don't usually have to write this out, but in the beginning it's going to matter. Okay, if we know that the square root of 16 is 4 and the square root of 25 is 5, we know that the square root of 21 is somewhere on the number line between the integers of 4 and 5. It's somewhere in here. So if I found a halfway point, like I would say there's 1, 2, 3, 4, 5, 6, 7, 8. So if I go in 1, 2, 3, 4, notice 1, 2, 3, 4, 1, 2, 3, 4. That's exactly halfway. In between 20, I would say, is 4.5. So we can kind of estimate this to almost 4.55, 4.6, and let me Pause the recording. I gotta grab my calculator. I take my graphing calculator and I hit second, go for the square root sign, and do 21. My guess was it's about 4.55, 4.56, 4.6 at the most. I end up, the answer is 4.58. So I guessed it's slightly more than 4.5. So I guess 4.55, 4.56, and so that is pretty darn close. The square root of 21 is 4.58. It's estimated, and we basically, because we're taking a square root, we use the estimated sign. Because it's not exactly, on my graphing calculator, anything that's not a perfect square is an irrational number, and it goes on and on forever. So even my graphing calculator says 4.582575 and then it cuts off all the rest of the decimals. This goes on and on forever. Okay? So let's try one. Okay, let's take the square root of, the higher the square roots go, the easier it is. When they're really low, there's not that many. So we've got the square root of 7. The square root of 7 falls between the perfect squares of the square root of 4, which is 2, and the square root of 9, which is 3. Oops. I don't know what I'm doing there. Square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, that's 3. So we're really looking at this one here. And if I find exactly the halfway point, I go in 1, I go in 1, I go in 1, I go in 1. The exact halfway point, again, is about right here. So that would be about 2.5. So this is slightly more. I would say about 2.6, 2.7, since there's less distance between the halfway point and 3. So it's more than 2.5, so 2.6, 2.7. And when I take the square root, second square, I find the square root of 7 is 2.6. So it's about 2.6. Square root of 7 is about 2.64. All right, I'd like you to pause that, and I want you to try that right now for 32. Pause the recording and see if you can figure it out. Whoops, didn't mean to do that. I don't know what's happening here. Meanwhile, you guys are checking on the square root of 32. Whoops, okay. Let's try the square root of 56. Pause the recording. Okay, the square root of 56 falls somewhere between, just after it is the square root of 49 and the square root of 64. So this is about 4 and 4. This is about 8 digits away. Okay, and this is about 1 and 6. This is 7 digits away. So which one is it closer to? This is the square root of 7. This is the square root of 8. Is it more or less than halfway? It's slightly less, so I'm going to say about 7.4. I'm going to say about 7.4. Let's check our answer here. Very good. I told you I could guess it within. Now, square root of 99 should be super easy. I don't need to keep listing all of them. We know it comes between the perfect square of 81, which is 9, sorry. And we have the next perfect square is 100, and that is equal to a 10. What's it closest to? Is it closer to the 10 or to the 9? How far is it from the 10? It's very close. So I might almost say it's 9.9. Okay, let's check that one. 9.95. Square root of 85. Square root of 85 falls between what perfect square? Pause the recording and see if you can do this one on your own. Now let's check our work. Falls between 81 and it falls between 100. This is 9, this is 10. This is only 4 digits apart. And this is 15 digits. So it's definitely much closer to the 9. Is it more or less than a halfway? Much less. So I'm going to probably guess like 4.2, 9.2, 9.3. Let's check our work. And I get 9.2. So 9.2, 9.3 is a good guess. All right, let's check the rest of our, pause the recording, and I want you to try 6 through 8 on your own. Let's see. For number 6, you should have gotten close to about 8.6, 8.7. Number 7, you should be around pretty close to 10.3, 10.4. And for number 8, 4.2, 4.3, 4.4. As long as you are guessing within a tenth of where it's supposed to be, within the correct boundary, I'm going to give you credit for that. All right, so let's go back to, I want to show you another way, okay? Let's take any number. Let's see if I can remember this. There's another method that you can use, and that's where you create a fraction. All right, so method number 2 is where we create a fraction. The square root of 35 falls between the square root of 25 and the square root of 36. See, to me, this seems much easier to just estimate it. I can estimate it pretty close to almost the nearest tenth, but I want to show you how we do this. So we know that it's somewhere between 5 and 6, so we go with the lower number. And you take the difference between 35 minus 25, and then you put it over the square root of 36 minus 25. Okay, 36 minus 25. So we end up with 5, and that is, let's see, 10 over 11. And when I divide 10 by 11, it goes 9 times, right? I have a remainder. It's going to go again. It goes 0 times. Oh, it goes 0 times. Then I bring down another 0. It would go. So if I simplify this, it would be 5 and 0.909, and they all repeat. Okay? So that's another way. Let's try another one. Let's start with the square root of, 42. So 42 falls between 36 and 6 squared and 49. So we know that it's going to be 6 something. We always go to the lower number. And the difference here is 42 minus 36 is 6. Okay? Over the difference here. 4. Let's see, it'd be 4 and 9. It's 13. It's a little bit less than half. It's a little less than half. So I'm going to estimate it at about 6.45. If I divide 6 by 13, it's more than 3. It's 4. 5 times Okay, so it's about 4. 4 times 3 is 12. Carry the 1. It's 5. 52. We have a remainder of 8. Bring down the next 0. So it's actually 6.4 goes into, we'll say it goes about 6 times. Let's try 6 times 3 is 18. Carry the 1. 6, 7. I have a remainder of 2, and we can keep going, but so it's about 6.46. Now, I had said to you, when I looked at that fraction, it's a little less than half, so I said about 6.4, 6.45. So I'm pretty close. Okay, one more time. The way we get the numerator is we subtract the middle number minus the low number, and we subtract the high number minus the low. Okay? All right, so these are 2 different ways. I don't care which one you use. I personally find my estimating to be a little bit quicker, but that is 2 different ways that we can work on perfect squares. Now, this says evaluate, round to the nearest hundredth when necessary. So you can see we're looking at the square root of 121 is 11. Number 2, notice there's a negative there, so this would be the negative root of 20. Okay. Okay, why don't you guys try the next 1, 2, 3, 4. Or why don't you just try the next up to 5. Pause the recording. Okay, let's check our work. 71, I'll use it both ways. 71 falls between 64 and 81. So it's going to be 8 and a fraction. That would be 6, 7. And here it's over 10. That's easy. So about 8.7. When I do the second square root, 71. Oh, I'm really far off. Because I got the square root of 71 is 8.46. Huh. Okay, I see what I did. I should have been doing 81 minus 84, minus 64. And that is 17. And now we're really dividing that out. So 7 divided by 17. Okay. 7 divided by 17 is 0.41, so it's 8.41. I will never ask you to round to the 100th. I will always ask you to round to the 10th. So 8.41, about 8.4. Really, since we are estimating all of these and we're cutting off their decimals, we should always be writing the about sign. Now, if I had done my estimating method where I thought it's between 64 and this is 81, these are 10 digits apart, and this is 7 digits apart. So it's less than half. It's not so close to the 8. Okay, so I likely would round it to about 8.3, 8.4. I probably would have gone to 8.3, 8.4, you know. And again, since we are just estimating, if you're within a tenth, I will accept that. Regular mathematicians do not estimate. They actually use a calculator. They get as close as they can with a calculator. And we leave our radicals, these symbols here, in reduced square root form. Okay? The next one, it's both a positive and a negative root. So this would equal plus or minus 9. We have to estimate the 18. 18 falls between 16 and 25. Notice it's 2 digits here. It's 2, 5, it's 7 digits here, so I'm going to say it's about 4.2, 4.3. Okay, if I take the square root of 18, I got 4.24, so pretty darn close. So if we were going to write this up, we're going to write it as plus or minus 4 2/10. Okay, now, square root of 99. I've got 2 plus. This is pretty darn close to 100. So I'm going to say the root of 100 is 10. So I'm going to say this is about 9.9. So what this means is 2 plus 9.9. Sorry, 2 plus 9.9. And this is 2 minus 9.9. Okay, so we get 11 9/10 or minus 9.9 minus 2.0. We end up with about negative 7 9/10. So we have two solutions. The solution here would be 11 9/10 or negative 7 9/10. Two solutions. All right, moving on. Okay. All right, perfect squares. As we've mentioned, you should know these numbers. They will come up over and over again. We know that if we divide all of our numbers into rational versus irrational, the definition of a rational number is any number that can be written as a fraction. So 0 is a perfect square, so we call that a rational root. 1 is a perfect square, so we call it a rational root. But 2 is not a rational root because it's not a perfect square. It would be called an irrational root. Square root of 2 is an irrational root. Anything that's not perfect is an irrational root. Square root of 3 is irrational. The square root of 4 would be rational. What about the square root of 5? Irrational. Square root of 6, irrational, because these are not perfect squares. Okay, square root of 7, irrational. Square root of 8, irrational, but square root of 9 is rational. Okay, square root of 10 is irrational. 11 is irrational. 12 is irrational. 13 is irrational. Square root of 14 is irrational, and so on. All my perfect squares are rational roots. Okay, we could go on and on with this, but so all of our perfect squares are rational roots. All right. As I said before, they're just basically our perfect squares. If you see a perfect square under the radical, it is a rational root. All right, so our next part that we are doing is we are looking at whether a number is rational or irrational. Okay, whoops, I'm just not, I don't know, it's not going. Not quite sure why. Anyways, pause the recording and let's look at the next few. Okay, and see if you can categorize these into rational versus irrational roots. All right, let's check our work. Square root of 50 would be considered irrational because it's not a perfect square. Whoops. Just when I wanted it to go, it's just not doing what. It's really bizarre. Okay, square root of negative times the radical 49. We call that symbol a radical. Okay, so the negative 1 times the square root of 49 would be, that would be a rational root because it's a perfect square. Okay, 50 is irrational, 62 is irrational, but 81 would be considered rational. And the negative root of 16 would be considered rational because it's a perfect square. Square root of 99, irrational. But square root of 121, since it's a perfect square, is rational. All right. Here we go. Let's try it again. Pause the recording and let's check our work. All right, let's check our work. So number 1 would be a rational root. Number 2 would be a rational root. Number 3 is irrational. Number 4 is rational. Number 5 is irrational. Number 6 is rational. 0 is a perfect square. Number 7 is irrational. Number 8 is rational. Number 9 is irrational. And number 10 is what we would call not a real number because it's not part of the real number system. The square root of negatives are part of the imaginary system. Just going to go back, do a quick little review. Remember, we have our natural numbers, our whole numbers, our integers. Remember, each one includes everything on the inside. Okay, and then our rationals. Negative 1/4, 0.3 repeated. As opposed to our irrationals, which are these are the non-perfect squares, the square root of 8, pi. It's a number, any number that goes on and on. Pi, square root of 6. Repeated decimals are rational, but non-perfect squares are irrational. Together, we call these the real numbers, the real number system. Now, outside over here is the square root of a negative, and we call those imaginaries. Because no number times itself will equal a negative. So now that we go back, I'm gonna erase this. So if you need it, stop the recording. Now when we go back and we see the square root of a negative, our answer is going to be not a real number. Rational and irrational are part of the real number system. So not a real number. Another thing that they could ask you is what integers this falls between. So you figure out, it says determine what 2 consecutive integers. You find out what perfect squares this falls between, and what comes before it is a 2. Square root of 4 is 2, and what comes after it, the square root of 9, is a 3. And so when they ask what 2 integers the square root of 7 falls between, it's between 2 and 3. Now you try the next one. Pause it and see if you can tell me. All right, let's check our work. 20 falls between 16, the square root of 16, and 25. The square root of 16 is 4, the square root of 25 is 5. So the square root of 20 lies between the integers 4 and 5. All right, square root of 85 falls between 81 and 100. So that falls between the integers 9 and 10. Okay, 45 falls between 36 and 49, so it falls between the integers of 6 and 7. Now the difference here is they're not asking us to estimate. If they asked us to estimate, we have to go at least to the nearest tenth. I don't care if you go to the hundredths place. If they ask us what 2 integers it falls between, it's a different skill set. So I think that's it for today. Let's see. just more of the same. You want to pause it, you can check the answers. And now, pause it again if you want to keep going. But I do believe that's, let's see, estimate each irrational root to the nearest tenth without using the calculator. This is basically the same thing that we've been doing. You can use either method, but this time we're going to the 10th. Okay. Let's look quickly at finding the side of a square. So if the area of a square is 49 square units, and we know that a square is equal to side squared, we can basically take the root of 49, square root both sides, and we know that the side is equal to either the negative root of 49 or positive root, but area can't be negative, so we know that a side is equal to the square root of 49, which is 7. Pause the recording and see if you can estimate 40. Now let's check. 40 falls between 36 and I'm going to estimate it. 40 falls between 36 and 49. So it's about 9 digits away here, and here it's 4 digits. It's less than halfway, so I'm going to guess it's about somewhere between 6 and 7. I'm going to say about 6.3, 6.4. Let's check our work. Wow, what an estimation. And that's it, my friends. Any questions? All right. That's it for today.